Welcome back for unit tests in AnyLogic. So in the previous videos, we have learned how to set up all the unit tests, and we have seen how to use assertions and annotations. On this one, we will learn how to structure the model in order to be able to use unit tests, because not any model can do unit tests so easily. You need to follow a structure, and we will talk about this structure. But first, when should you use unit tests, or why do you use it? Because unit tests are meant to avoid breaking features that are already built in the past. But these unit tests take time to do. So when should you do it, and when shouldn't you do it? Reasons why to do it is because the project is very long. Second, you are working with other people who will touch what you have done and may break your features. Or you are working with a model that is live, so you have to maintain it, it's used in the long term, or maybe you're creating a library that other people are using. These things are good for unit tests. When you shouldn't use unit tests is, for example, when you're doing a demo model, there's no reason why you should use unit tests, or when the project is very small, you have to make a trade-off, because unit tests take time. If your deadlines are short, maybe you shouldn't do unit tests. But this is something you will learn by own experience. Anyways, let's go to AnyLogic and see how the structure is done. Okay, so in this example, we will do something very simple. We will have some boxes that go through a service that use a resource, and then they go to a sink. Very simple model. And in here, we already built the structure with run all test and tester. We have seen that in other videos. Main test that has the basic structure to run a custom experiment. And you have a box, which has nothing, and a resource that has also nothing. So we will do everything in main here. So in main, I created a few things. So this is part of what the structure should be. So let's talk about that. You need, and this is mandatory, a scenario object. This scenario object has all the input data that you will need. Either you get it from a database or Excel or wherever. This has to be placed in a data object, or maybe multiple data objects, that's up to you, but at least one. You cannot and should not have parameters, like time to do something, for example. Parameters should not be here. So all the parameters will be in the scenario object. The only parameter I'm allowed to use is this one that I will explain in a bit. So also, another thing that is very important is that nothing should be done with the AnyLogic automated things. So for example, if you create a source, you can say, the arrival rate is 4 here. No, this is something you shouldn't do. Instead, you should use an arrival rate of 0, and in an initialization function, you should define the rate that the source will use. So you don't define it automatically here. Why? Because if you put a 4 here, your tests will use that 4, and you don't want that. You want to control everything that is happening. Another example here is a resource pool. If you add a resource pool, you can say, the capacity is 2. Or maybe you want to put a parameter here and put the name of the parameter in the capacity. No, the capacity will be 0, and you will define the resource pool capacity in an initialization function. So you will control everything that happens in the model by yourself. You don't use automated things done in AnyLogic, which is something we like to do, but if you want to do tests, you cannot do it. Okay, so then in main, I will have this start up where I create my scenario. And let's see, the scenario here has only one parameter called number of resources. And let's say that to create a scenario, you define a new scenario, for example, with one resource. So in main, you have create scenario and then init, which has whatever you want to do to initialize your model. Right now, there's nothing, but there will be something always. Now, let's focus on this auto init. This is the only parameter I can use. So this is a Boolean, which is always true. Why do I do this? Because when I go to the test, I don't want the model to be initialized with what I said to be done in the model. Instead, I want to use my own initialization depending on what kind of test I'm doing. So that's why I do this, which will avoid the initialization, and I will create my own initialization in my tests programmatically. And you will see how we do that. Now, you have another option, which is also used by many people, that instead of using this if auto init, instead you use a button. And in this button, you will create the scenario that you need, and you will initialize the model. In this case, you run the model, you pause it in order to upload your Excel files or do whatever you need to do, and you will only initialize it when you press the button. So that makes the simulation independent from the tests as well. Either you use a button or use this auto init or something similar, it's up to you. I like to use this because I find it annoying to have to press a button, but maybe you prefer that. Up to you, that's your style. Perfect, we have our setup. But before we continue, let's talk about the different ways in which you can do unit tests. There are 3 ways. First one, it's called test-driven development, which means you do the test first, then you do the feature until the test passes. The second one is you do the test while you're doing the development. And the third one is you do the development and you do the tests later, either immediately after the feature or maybe in the future. That depends on you. Now, the test-driven development, which is the first one I mentioned, is very, very slow. So what is the advantage is that you are forced to think about the test before you do something in AnyLogic, which forces you to really think on what you're doing and what you want to achieve. You don't improvise, so that's why the test becomes your kind of documentation of the model, but it's very slow to do. The last one is the test after the development. It gives you more flexibility because you can decide to either not do tests at all or maybe do some tests. And what is the problem? Is that you become a little bit biased because when you do a feature and you think about what the feature should do, you're biased because you already did the feature. So this can be problematic, but it's definitely a faster way of doing models. But at the same time, it gives you flexibility on whether you want to do a test or not. This is something you need to define by yourself depending on how much time you have to do the models, how important the tests are, etc. This is something you learn with experience. Okay, back to the model. What we want is to use a source followed by a service using a resource and then a sink. But let's keep it simple, but we will do a test-driven development. So let's do a test before the feature. And I will say that the test will be that the agent enters the system and exits the system. So I created this test. It's called box enters and exits. So what I'm going to do, remember, I will need to do engine.runFast at some point. But before that, what I need to do is to inject an agent. So we create our scenario with one resource. We inject one box into the system. Then we count how many boxes exit. And then we assert equals 1, which is the expected value, and boxes out, which is the actual value. Additionally, we will need to initialize the model because this will be initialized with this scenario. Now, you can notice here that the inject box function doesn't exist. That's why you get an error. And that the count exit boxes doesn't exist either. This is part of the test-driven development, which means that you create functions that don't exist and you get errors, and then you have to fix the errors first and then create the feature. But to fix the errors, we need to create the model. So first we will create the inject box function. Okay, so we have the inject box function, which takes as an argument the number of boxes, and it loops through this number, and then it creates a new box, and then that's it. If I compile, I still have a problem. Count exit boxes doesn't exist. So we need to create that function. So what this will do is it will count how many boxes came out of the sink. We can create a resource pool. Remember, capacity of 0, and a service, and this service uses this resource pool. Now we compile it, and everything is okay. In this function, there's no more errors anymore, because I created the two functions that were missing. But if I run all tests, what happens? The test fails. The expected is 1, but none passed. Why is that happening? Well, this is the initialization part. Remember that the resource pool is 0. So when the agent enters, the service has no one to take care of this box. So in init, what I will do here is I will set the capacity in the initialization function. And this capacity will be based on the number of resources that I created in my scenario. Remember, here I created a scenario with 1 resource, which is what I need to pass the test. Now I run all tests again, and now all tests passed for main test. So what we did here is called test-driven development. We did the test, it failed, and we didn't finish our work until we finished the test. Or in other words, we didn't finish the feature until the test passes. Now you have things as service and resource pool. These things you don't need to test them because they're already AnyLogic features. So you don't need to check if the service is working. But it's good to check if the agent went from one place to the other, because that means in all subsequent things that you will do, you will always check if the boxes ends its process, which is good. So that's it. This is the structure you need to follow. These are the rules, some of the rules you need to follow. The rest is for you to explore.